So far then, we have looked at if we have the mass of a solid, that we will use our triangle or our calculation that goes mass is Mr. moles, and we'll be able to calculate the moles from the MR. We've looked at if we have the volume and concentration of a solution, so that's when we've got a solid and we've dissolved it in water, that moles are very clever, and we've calculated moles of a solution. And we've looked at gases, and we've said that if we've got gases, we've got PV equals nRT, and so we've been able to calculate moles of a gas. But what if we've got a liquid? A liquid is not a solution. A liquid is a solid that has been melted. How would we calculate moles of a liquid? We're not going to have a concentration, so how would we calculate moles of a liquid? And to calculate moles of a liquid, we're going to have to use the liquid's density. So that's what we're going to look at now. How would we convert density, given this symbol rho, of a substance? If you find using that little Greek symbol difficult, you can just use a D for density in chemistry. So if you find using that symbol difficult, you could just swap to a D for density. But the density of a substance is its mass per unit volume. So if we put our density here, and then we've got our mass divided by our volume. And the units of that can be different depending on the context, but in chemistry it's generally in grams, so the mass is in grams and the volume is in centimetres cubed, so it's generally in grams per centimetre cubed. So we would know that the density of water is 1 gram per centimetre cubed. That means that every centimetre cubed of water has a mass of 1 gram, but we can work out masses from other densities for other liquids, and once we know the mass, we can work out moles of a liquid using mass is Mr. moles. So 50 centimetres cubed of ethanol has a mass of 38 grams. Calculate its density. So density is mass over volume, so it has a mass of 38 grams and a volume of 50 centimetres cubed. So in grams per centimetre cubed, its density would be, you just type it on your calculator, 0.76 grams per centimetre cubed. Notice we've got that minus because we divided by centimetres cubed. So in this question we've got a number of moles. So we've got the number of moles of pure platinum, and we're being asked to calculate density in kilograms per decimetre cubed. So we've got nothing in kilograms at the moment, and we've got nothing in decimetres cubed, so we're going to have to do some work here. We've got 550 moles of pure platinum. Can you work out the mass of platinum from the moles? So mass is Mr. moles, so go to your periodic table and find the MR of platinum and calculate the mass of 550 moles. Pause the video and do that now. So the MR is 195.1. Times that by the number of moles and we get a certain number of grams. Now our question is about asking us to do something in kilograms, so I'm going to convert this to kilograms now. I'm going to get 107.305 kilograms. And then it wants the density in kilograms per decimetre cubed, but we've got the measurements of the bar in centimetres, so we could work out our volume. It's 10 by 10 by 50. So that is 5,000 centimetres cubed. So then we could use our conversions to work out what that is in decimetres, which would be 5 decimetres cubed. And now we're ready to calculate a density in kilograms per decimetre cubed. So 107.3 divided by 5, our density is 21.5 kilograms per decimetre cubed. So pause the video and have a go at this last one yourself, see if you can work your way through it. Okay, so it's quite a complicated question, this. The first thing I'm going to do is get some marks. I've got a density and a volume. I'm going to work out a mass. Now that I've got the mass, I'm going to use the MR to get the moles. So I'm scoring 2 marks even if I can't complete the question. Now this is the number of moles of actual sodium chloride. So how many number of moles of ions are there? Well, every NaCl is made up of two ions, an Na plus and a Cl minus. So for every one NaCl, there are two ions. So I'm timesing by 2 to find out the number of moles of ions. And we've got the number of moles of ions there. Now to find out the actual number of ions, remember that the mole is just like saying a dozen or a pair, it's a physical number. I'm going to times by the Avogadro number, that's the number of anything in a mole, to get the actual number of ions. So when we're working with densities and liquids, we're going to need to convert. So we've worked out that we need to use density, and we were saying our density triangle looks like this, and then we're going to use the mass is Mr. Moles calculation to find the moles. So that's how you would calculate moles of a liquid. So we've got solids, solutions, gases and liquids.